Okay, friends, very good evening. Uh, Today we are going to discuss about the Smith chart plotting gamma. So, how this gamma can be plotted. So, in the year 1939, developed a polar chart for calculating transmission line characteristics. This chart is called Smith chart. It is a graphical representation of the transmission line. So it consists of two sets of orthogonal circuits which represents the values of normalized impedance. One set of circles represents the resistive component of the normalized impedance. This set of circles are called OR circles. The second set of circles represents the reactive component of the normalized impedance. These set of circles are called X circles. First set of circles are called resistive components of the normalized impedance or R circles. Second set are known as X circles. Gamma L is equal to ZL minus Z naught by ZL plus Z naught. So gamma is equal to ZL by Z naught minus 1 by ZL by Z naught plus 1 is equal to Z and L minus 1 is the normalized impedance by Z and L plus 1. NL plus 1. So ZNL is known as the normalized impedance. So gamma is equal to ZL by Z naught minus 1 by the relation by ZL by Z naught plus 1 is equal to ZNL minus 1 by ZNL plus 1. So the relationship between the normalized load impedance and the gamma is normalized load impedance and the gamma is by unique. Knowing one is equivalent to knowing the other. This observation is important because the familiar curves of the Smith chart are simply a plotting in the gamma plane of contours of constant resistance and reactance. So here two planes are given. One is impedance plane and the other is one is impedance plane and the other is gamma plane. So impedance of Z and reactance of Z. So here also phi and the impedance plane is known as vertical and the pi plane is known as circles. The mapping of constant resistance lines in Z plane to circles in pi plane. Mapping of constant reactance lines in Z plane to contours in pi plane. So the bottom half of the Z-plane maps into bottom half of the Z-plane maps into bottom half of the unit circle in the phi plane and thus capacitive impedance are always found here. Similarly, the top half of the Z-plane corresponds to the top half of the unit circle and inductive reactance and the inductive impedances. Progressively, smaller circles of progressively smaller circles of constant resistance correspond to progressively large resistance values. The point gamma is equal to minus 1 corresponds to 0 resistance and the point gamma is equal to 1 corresponds to infinite resistance or reactance. So the Smith chart is like this with the vertical lines, horizontal lines and also the small circles. Okay. radially scaled at a 2-volt load and 2-volt generator. So constant reactance, constant resistance, inductive values above and capacitance values below. Okay, constant reactance means lines are representing the constant reactance and the resistance means circles represent the resistance. Inductive and capacitive. Reflection coefficient for short circuited line. For short circuited line ZL is equal to 0. We know phi L is equal to ZL minus Z0 by ZL plus Z0. So here phi L is equal to minus 1. Substitute ZL is equal to 0 in the above equation. Phi L is equal to 0 minus Z0 by 0 plus Z0 is equal to minus 1. Phi L is equal to minus 1. Sorry, gamma L is equal to minus 1. Reflection coefficient for open circuited element, that is ZL is equal to infinity. Here phi L, here gamma L is equal to 1. Reflection coefficient for mature line, that is gamma L is equal to 0. The reflection coefficient varies from minus 1 to plus 1. Minus 1 to plus 1. Substitute ZL is equal to Z0 in the above equation. Gamma L is equal to Z0 minus Z0 by Z0 plus Z0 is equal to 0. Note the reflection coefficient varies from minus 1 to plus 1. Minus 1 to plus 1. VSWR ratio, voltage standing wave ratio. Here it is defined as the ratio between maximum voltage to the minimum voltage. VSWR is equal to S is equal to V max by V min is equal to Vi plus Vr by Vi minus Vr, that is equal to 1 plus Vr by Vi by 1 minus Vr by Vi is equal to 1 plus gamma L by 1 minus gamma L. S is equal to 1 plus gamma L by 1 minus gamma L. From the above equation, we can write that phi L is equal to, or gamma L is equal to S minus 1 by S plus 1. V max by V max by V min. Vi plus Vr by Vi minus Vr is equal to 1 plus gamma L by 1 minus gamma L. So here S is equal to 1 plus gamma L by 1 minus gamma L. So from the above equation we can be written as pi L is equal to S minus 1 by S plus 1. S minus 1 by S plus 1. Voltage standing wave ratio for short circuit elements, that is the VSWR for short circuited can be derived by substituting gamma L is equal to minus 1 in VSWR as below, that is gamma L is equal to minus 1. Here S is equal to 1 plus gamma L by 1 minus gamma L. So S is equal to 1 plus 1 by 1 minus 1, that is equal to 2 by 0 is equal to infinity. S is equal to infinity. The VSWR for open circuited can be derived by substituting gamma L is equal to 1 in VSWR as below. S is equal to 1 plus 1 by 1 minus 1 is equal to 2 by 0 is equal to infinity, that is S is equal to infinity. 1 plus gamma L by, so here VSWR for mature line. So VSWR for mature line can be derived by substituting gamma L is equal to 0 in VSWR as below. S is equal to 1 plus gamma L by 1 minus gamma L. S is equal to 1 plus 0 by 1 minus 0 is equal to 1. S is equal to 1. The S varies from 1 to infinity. Next, ZL is equal to 50 plus J 50 ohms. Z0 is equal to 50 ohms. Gamma L is equal to ZL by Z0 minus 1 by ZNL minus 1 by ZNL plus 1. Here ZNL is equal to 1 plus J1. 1 plus J1 or R dash into X dash. So here the value can be R1 and X1, resistance value and reactance value should be plot like that. Okay, should be plot like that. ZNL is equal to 1 plus J1. Next here also the same like this. The Smith chart will be platted. What are the properties of Smith chart and what are the applications of Smith chart? The properties of Smith chart: plotting of an impedance, determination of SWR, determination of reflection coefficient, location of voltage maxima and minima, open and short circuited lines, movement along the periphery of the chart, and last one, mature load. So these are all the properties of Smith chart. The Smith chart properties: plotting of an impedance, determination of SWR, determination of reflection coefficient, location of voltage maxima and minima, open and short circuited elements, movement along the periphery of the chart, mature load. So what are the applications of Smith chart? The applications: Smith chart as an admittance diagram. So admittance diagrams: im- converting impedance into admittance, determination of input impedance, load impedance, and open circuit and short circuit line impedances and admittances. So these are all the properties and applications of Smith chart. Okay.